Okay, the factorising sheet. So remind ourselves we're looking for a common factor. What's common to both terms? Clearly they both have an A. A times, we'll need another A and a B to give me an A squared B term, plus just a C to give me the AC term. Right, next one, common factor of 5. They both have an A and they both have a B. Just check you get an A squared B, 5A squared B there. 2 5s are 10. We'll get an A and we'll get a B squared term. Right, now these have an R in common. In fact, they have an R squared. Both term has the R times R factor. So we'll bring that out in front, factorising out as much as we can, leaving me with M minus R, and just check going backwards, R squared M minus R squared N. Common factor of 2. Now they both have an A squared, so we're pulling out as much as we can, and a B to the 1. Asking ourselves what we have to multiply by to get back to that term. We'd need a 3, the A squared is there. We're going to actually need a B squared to ensure I get the B cubed term when I multiply. In this one I can see I've already got the 2A squared B, so in fact all I want is one lot of the 2A squared B. 2A squared B times 1 ensures that it stays 2A squared B. Similarly with this one, both have an X, both have a 2X, leaving me with X plus 4, 3M from both, and an X from both. You'll notice that this one is a quadratic, so if we look at the quadratics, that one is a quadratic. This one here is actually quadratic with an M variable. Quadratic. Those ones are all what we call the one bracket quadratic, because when we normally see a quadratic like number 9, we expect to get 3 terms, the x squared term, the term with the single variable, and what we call the constant term on the end. Now you'll notice with number 5, 6, 7 and 8 that constant term is missing. And when the constant term is missing, it becomes a one bracket quadratic. It's helpful for when you need to factorise. So back to our quadratics, we always start with the third term. We're looking for two numbers that multiply to give me 15. 3 and 5, 1 and 15. And we want to be able to add or subtract those two numbers to get minus 2. So we should have written down the brackets. Clearly it's going to be 3 and 5. Now I want to get negative 2 when I add or subtract. So 5 is the bigger number, that needs to be the negative, so that I'm starting at negative 5, adding on 3, and I'll still be down at a negative number. Negative 5 plus 3 is negative 2. Right, 21, clearly it's going to be 3 times 7, and thankfully this one is all positive, so we can keep the plus signs. Right, next one, 2 times 7, 1 times 14, and I can see from the 9 that it's clearly going to be a 2 and a 7. Now this is one where, to ensure we get a positive at the end and a negative in the middle, both two signs need to be the same to get that positive in the end, but to add them together to get negative 9, we're going to need to add negative 2x and negative 7x. And of course you should be expanding each one back to make sure that you get back to the question. Number 12, 7 times 5. This time we want a positive 2x, so choose the bigger number, that should be the positive, so that when I subtract the 5 I'm still at positive 2. 2 times 1 for the 2. Positive, so that tells me that both signs are the same. Obviously I want to add them to get negative 3. A bit harder with the 16, you might need to consider 2 times 8 actually, and 4 times 4, and of course 1 times 16. Now to get 6 there, we're going to need an 8 and a 2. I want to add those, add or subtract to get negative 6. So the bigger number must be the negative. So negative 8 plus 2 gives me negative 6. Right, this one is harder, and the reason is because of the 2 in front of the x squared. It's always harder with a factor in the front there. And what we always do is look for a common factor first, and that should be written at the top of your exam paper. Common factor first. It's the golden rule for factorising, because I can see that 2, 4 and 16 all have a common factor of 2. So 2x squared plus 4x minus 16. Now looking at that, I can see that we can factorise that. It'll be a 2 and a 4 plus 4 and a minus 2. Now you just check that by expanding it backwards. Right, now we're running out of room for number 16 here. I can see there's a common factor of 2, 2 and 24 and 40. We're running out of room quite drastically there, so perhaps, right, we might just need to pull up, see how much space I've got at the bottom there, just enough. Once again, a common factor of 2. And looking at this bracket here, I think it can be factorised further with a 20 has factors 4 times 5, 2 times 10. We need to get 12, so clearly it's a 2 and a 10. Right, number 19. Now the interesting thing about 19 and 20, I can see they're a quadratic, but what we're missing this time is the middle term. And when you're missing a middle term, it's what we call the difference of two squares. This is x squared, this is actually 6 squared. So in our brackets we'll need a minus 6 plus 6. Remembering that when I expand that, I get x squared plus 6x minus 6x minus 36, and those middle terms disappear, which is what's happened. Right, so looking at the next one, we identify x squared and we identify that 49 is 7 squared. So once again it's a difference of two squares, minus 7 and a plus 7. Carrying on with 21. Factors of 16. 4 times 4, 2 times 8, 1 and 16, and clearly it's going to be plus 4. And of course another way of writing that would be x plus 4 all squared, which you don't have to do, but we can see that this one is what we call a perfect square, because it's x plus 4 times itself gives us that. And similarly with this one, to get 25, 5 times 5. So once again I can rewrite that as x plus 5 all squared, which is again is a perfect square. It's a number just times itself. Similarly with the next one, 3 times 3. Both going to be minus 3s to ensure we get minus 6x in the middle, and we can write that as x minus 3 all squared. And lastly, same thing, 2 times 2 to get the minus in the middle, and we could rewrite that as x minus 2 all squared if we wanted to.